Okay, we'll just start with, I usually start with a metal stairs manual. I guess Synergy's kind of had a long history where they've started with, it was kind of just specialty guardrails, where there was an existing stair. And we would go out and site measure the stair and then supply the guardrail for the stair. A lot of that and other specialty stuff like wall panels and different things. And then they kind of got into the malls where they go into large malls and rip out the existing guardrail and then come back at night and install new guardrails, glass and different types depending on what the architects wanted. And then the last few years they've gotten into these modular stairs, which is basically the whole stair and the guardrails and everything for the stair. So I usually start with the stair manual. This is an NAAMM, sorry, tongue twister, manual. And I don't know if it's at Synergy's office there somewhere in their files. I'm sure it is. But what I can do is at the end of this meeting or whatever, I can send this to you by email so you have it. But it basically just goes through all the different types of stairs. Your guys' history, have you kind of worked on stairs and that a little bit, or different structural and miscellaneous metals?
More Bill than me.
Yeah, I've been working probably the last 3 or 4 years at a company that was manufacturing the stairs for you guys.
Ah, okay.
It was a specialty. Both Tim and I were both at Specialty Welding.
Oh, Specialty Welding. Okay, then Amazon. That's right, Amazon Hank. You were
Yes,
working on that.
Yeah, just did that one.
Yeah, I kind of did a little bit of, I guess, work on that as well, as far as just kind of checking drawings as well. I know Adam Rosenwasser and Eduardo took on the bulk of work, I guess, as project managers on that job. But
yes,
yeah, that was a nice job.
I just got pictures this morning. It looks like it installed really nicely.
Oh, okay.
Yeah.
Are they into the finishing the stair mode right now, or are they still just kind of finishing the install of the stair?
I think he said yesterday that they'd be painting this week. I think they're ready to paint.
Okay, I see. Great. Okay. Yeah, like I was saying, this manual just kind of goes through all the different types of stairs that you run into, but I'm sure you guys are kind of probably seen quite a few different types of stairs. For myself, before I started with Synergy, I was into structural and miscellaneous metals. So I did kind of a lot of your typical pan stairs and stuff.
Mm-hmm.
The stairs with Synergy now, some of them are pretty nice, but the treads and risers and stuff like that can change quite a bit in that. But most of the stairs, it's still your typical channels or HSS tubes for the stringers. So it just goes through different stairs. We don't really do ship ladders. So something to reference if you're ever looking for it. Gets into some details in that on different types of stairs. We do, now that we're supplying a total modular stair, sometimes we do supply the treads, terrazzo treads or concrete treads or whatever the customer wants. Sometimes that's part of the stair package. Just different details. A spiral stair, we do spiral stairs from time to time. They can be interesting because the finishes and things on them are always varied. And then it kind of gets into some of the construction details, just landings, different types of treads. We don't usually use the these are more commercial type of treads or whatever. Like I was mentioning, we do supply the treads sometimes for stairs. Do a lot of wood treads, but usually the wood treads and risers are most of the time by others. Different types of nosings, but that'll usually show up on the architectural drawings, or the project manager would let you know what type of edgings they have on the stair if they're required by the architect. Different types of handrail ends. We don't really do a lot of picket rails. We do a lot of glass rails, I guess, mostly. Although I think Amazon Hank, though, I think that had pickets, didn't it? Stair F, I think.
See, F, we didn't do F.
Okay.
We did J and H.
Okay. Yeah, I think stair F, that was kind of the big one that went up quite a few floors, but I think it wasn't really pickets. I think it was kind of bars, I believe, for the pickets. And then it kind of gets into the glass guardrails, which we do a lot of. It's usually glass is sitting in a shoe, aluminum shoe. Different types of shoes depending on the thickness of the glass. Different types of setting the glass in the shoe. Sometimes it's Porrock, just kind of a cement that kind of sets the glass, and then other times we use a removable glass system, which kind of clamps the glass into place. So if the glass breaks or whatever, it's easy to fix it or replace it. So different shoe details, different handrail moldings in here that we don't really use a lot of these. A lot of the handrails are just stainless steel tubes or wood or different types of things. And then it gets into more handrail shapes. And these are usually defined, I guess, in the very beginnings of the job. We usually have DA design assist meetings that all this stuff is kind of sorted out. And if you ever have questions or whatever, it's usually you go to the project manager and they'll assist you on whatever questions you have regarding the job and types of material. And then in the back of this, it just kind of gets into different kinds of, I guess, what's this, loads, which we don't really do. The engineering usually takes care of the loads on the stairs and comes up with a thickness of like tread and pan materials and the stringer sizes. So we don't really get into that. Grading, we rarely use that. That's kind of more of a commercial type thing. And then it just gets into loads and stuff, but we don't really get into that. That's more engineering. So it's just kind of a handy manual to have if you're looking for details or whatever.
Mm-hmm.
This kind of gets into guides, specs, specifications a little bit, different types of material types. Fabrication and glossary. So yeah, so it's just, like I say, kind of a good manual to have to check into it if you want to. But usually the project manager would answer most of your questions, or they're figured out in, we do usually design assist meetings in the beginnings where a lot of things are figured out as well as far as the stair. Next on the list, we have accent standards. This standards manual, same thing. I'm not quite sure where it is in the filing system. That's the new system that Synergy has, but I'll send it to you. It's kind of outdated. I think, when is this? Does it have a date on here? Yeah, this is like from 2013, so it's it's 10 years old already. This standards manual has kind of been, I think I started it probably years and years and years ago, and it just kind of grew and grew and grew. And then back in 2013, I think it was kind of downsized and to what it is today, but it's kind of outdated. It still kind of refers to things like CDs and different things like that. So it it goes back a little bit, quite a ways. We can just kind of flip through it, but I'll send it to you. A lot of this stuff doesn't apply anymore. It's just kind of a glossary of terms in the beginning. And we get into standard abbreviations. We don't really use this that much anymore. We have, I can just open up something else here now. We actually have, this is our standard title block cover page that we use for drawings, and there's a zip file with all the different sheet sizes, like 24 by 36, 11 by 17 for shop drawings, that type of templates in there that I'll send you guys as well. And we actually have now on the cover page, we actually have some abbreviations, glossary of what different types of abbreviations that we use. So this is kind of overrode, I guess, by what's on the cover sheet. Memorandums and emails, that's something old that doesn't apply anymore. Technical info, building codes. Technical info, well, that doesn't really apply anymore. And building codes, I'll show some stuff on building codes a little later, but building codes, if you guys have been in the stair industry for a while, you probably know most of the typical building codes. And if I have a problem with a building code now, I just Google. all hail Google.
Yeah.
And find it on there, or ask one of my one of the detailers at Synergy or whatever. Somebody usually knows. They're mostly typical, although I've been finding though as we go into New York and that they have a little bit different yep. Building codes.
Special codes.
Yeah, special codes. Submittal or action drawings, general detailing, and this is 20 the different sheet sizes and that's kind of like I was saying. I'll send you the templates for these drawings, for these templates after the meeting. So that covers that. Submittal or action drawings. Usually we'll put a key plan on one of the drawings. I think I probably have an example here. I don't know if this one has this one doesn't have a key plan. Let's see what we got here. Yeah, this is an example here. This is a key plan that's sometimes this one they put it on the cover sheet, and there's also the second page is actually a key plan, a larger key plan. You can do either or, doesn't matter. Kind of depends on the size of the job. If you have multiple stairs or something on a job, but usually we'll add a north arrow. Just kind of helps out guys in the building or whatever to orientate themselves. Are we standards there? So I usually add that somewhere. This does not apply anymore. Submittal or direction drawings. Yeah, the numbering system, we've kind of worked that out. We've got a number down in the bottom here. Usually the drawing number is dictated by the item. And the item is usually dictated by scope of work, which sometimes, not all the time now, but sometimes you'll get a scope of work, which if there's 6 stairs on a job, there might be 1 stair that's item 1, there might be second stair might be item 2, third stair might be item 3. There might be guardrail around the opening, it might be item 4. It might be smoke baffle glass underneath, that might be item 5. But usually the project manager breaks that up and lets us know what the item numbers are. So a submittal erection drawing the item number comes first, and then the drawing number comes second. So this example here is item 04 on drawing number 2. But as you get into the drawing system, you'll see, and I'll send you a couple of sample jobs as well that kind of will assist you in that. The first submittal erection drawing usually has, well, this is kind of all on the new cover sheet we have now that everybody's using. So it's basically got the general notes that are usually standard. They rarely change. Material and finish notes, they would change basically based on what the job is. The types of steel, types of stainless steel, or the finishes. If there's mesh guardrails, the top rail material, whatever it is, if it's painted, that's where all this is added into the material and finish notes. So it kind of, this is just a standard that they put on the cover sheet, but it would change to suit your job. Usually that all the material and finishes, that's kind of figured out in the beginning in design assist meetings, or from your project manager. I usually do a lot more checking now. So what I do in the beginning of jobs is I'll get the architectural drawings, the structural drawings, and the specs. And that's usually what I'll use to check the material and finish notes, plus whatever I've got from the design assist meetings or from the project manager. So that's on the erection drawings cover sheet. And they've also added logistical notes and for the freight elevator. Sometimes now that we're into modular stairs, they need to be made in a certain size to fit through a window or up an elevator or crane through a roof, or however they're getting it into the building. That's usually figured out in the beginnings as well. So we've started adding that to our erection drawings cover sheet as well. And additional notes, that's usually just the if they're 100 CD set and the date of that set, we usually add that on the drawings here for both the architectural and the structural. I'll show some examples as we move along. So that's kind of the stuff that's on the cover sheet now. Examples for filling out title block lots. We just kind of looked at that. And I'll show some examples later on. Item number. That's what I was referring to, and the item number and scope of work supplied by the project manager, although they don't always supply a scope of work, but the project manager should be able to help you out with which item numbers to use on the job. Detail reference numbering. This is kind of your typical call out, which I'm sure you guys are familiar with. And again, it's the item number, and then this would be the drawing number. Field check drawings. We used to cloud a dimension if we needed it to be field check. Now we put VIF on the drawings right here. So we don't cloud drawings anymore. Mark numbers, rectangular box, we don't do that. That's just in regards to, on the erection drawing, you'll have a mark number for a post or a piece of glass or whatever. We used to put a rectangular box around it. Doesn't matter now. just as long as the mark's there. And each piece shipped to site must have a mark number on it, which, of course, do not email. That was just about file sizes. Doesn't really apply anymore. Marking numbers when drawings are sent to the project manager. I kind of use this type of system with the project number, the item number, what it is, and then the drawing number, and then the rev number. As we've gone along, different drawings I've gotten from different outfits, that doesn't always apply. So it's not really standardized, but I guess it should be standardized. But because everything goes through so fast, you kind of usually leave it the way it is. But that's kind of a marking we kind of like to follow, something along that line. If there are more than 2 PDFs, submittal direction drawings, send email. That's kind of outdated. Except for key plans, details on each submittal direction drawing shall be limited to 1 item number. Don't do that anymore. Sections on submittal direction drawings should be detailed as the biggest scale possible. That's kind of a typical thing. We usually elevations, plans, 1/2 inch to 1 foot, maybe at the smallest. And then you get into details in that we're usually around 3 inch to 1 foot scale, maybe 1.5 inches to 1 foot if need be. But the bigger the better. Like, if you guys probably know that, it's better to have a large detail on a drawing than a very small one. Easier for everybody to read. Do not use opposite hand or left and right anymore. We don't. That's kind of an old note. We used to a long time ago use right and left. So we don't do that anymore because it's basically mirror image and you've got the left. So it's just easy enough to do a mirror image and then you've got your left. Before commencing drawings, discuss with accent. Tolerances, it's usually a 1/16 or an 1/8 of an inch, I believe. And that's kind of already built into our general notes. Fabrication tolerances will be an 1/8. So that's kind of a typical note unless the PM tells you differently. Location of field splices for rails and lengths of rails. Sometimes when detailing our handrail, we put our field splices kind of in locations that dictate based on the length of material ordered. These are kind of standard lengths here so that there's not a lot of waste of material. It's not critical, but and you can always weld a couple pieces together if you need to or whatever, but we usually try and like to keep so we're not wasting material. Need to ask the PM maximum lengths of cladding and glass. Cladding is usually dictated by bending. If the cladding's bent, what the shop can bend sizes, usually around 10 feet or so, but need to check with the PM, and that could dictate your cladding lengths and cladding sizes. Usually the cladding joints are lined with glass joints if there's glass. Sometimes they're aligned with millwork. Sometimes there's reveals in millwork that you need to line up with. But that's stuff that can be discussed with the PM. Slotted holes or oversized holes, usually with posts, connections, and that we like to use either oversized holes or slotted holes of some size, just to give us a little bit of the guys on site a little bit of adjustment. But that can be discussed with the PM.
Do you have a standard, Dan, on oversize? Like for a 1/2 inch bolt, 9/16 hole?
Yeah, I usually go to, are you familiar with the AISC manual? I usually look in there for whatever they suggest for oversized holes, but it's
Okay.
usually like if I do a base plate that's got an anchor, I'll usually, like if it's a 1/2 inch anchor, I'll provide a 5/8 diameter hole.
Okay.
When you get into a bolted connection, the oversized hole can kind of vary on how much slop you want for moving it around or that, but it would kind of be, if you made a bigger oversized hole, the engineer would need to sign off on that. But I think in the manual, the AISC manual, I believe it's probably about an 1/8 of an inch. It's usually like for a 3/4 bolt, it's 13/16, but an oversized for 3/4 bolt, I think is 7/8, I believe. Might be a little bit bigger.
Yeah, we always use 16th over bolt size.
Yeah, that's
in the
kind of
shop.
a
That was just
standard.
kind of a
Yeah,
standard we used, so.
yeah,
Okay,
yeah. But if you're looking for some kind of a little bit of slop and to move it around or whatever, and you want to go to an oversized hole, it's best to check with the engineer or whatever to just make sure to see what they would suggest, I guess.
okay.
Or you could come up with a hole you want to use and they could yay or nay it, I guess.
Mm-hmm.
Materials shipped loose. That I think was kind of based on getting it into the material, into the building, size wise, and I guess fitting on a truck as well for shipping. Those are kind of some logistics that are discussed in the beginnings of the job. Now that we're into the modular stairs and that, we kind of have to look at the actual size of a stair module that we're shipping, make sure that it can be, number one, fit on a truck for shipping, and number two, brought into the building by whatever access we have. Before commencing drawings, field welding. Yeah, now we haven't really standardized yet a typical, now that we're putting stairs together, a typical field welding joint. We've kind of been using a couple of different ones. That's something we will probably standardize at some point. So there are different, we do a lot, the stringers, HSS tubes, we do a lot of field welding tubes together. And we're kind of using a couple of standard details, but it needs to be standardized. But that can be discussed with the project manager. You have to, I guess, number one, find out where you're going to put your splices, and that goes back to the shipping size and bringing it in the building, and where you're going to locate those joints. And we're actually looking now too at to try and get away from field welding. We're kind of looking at I think it's called Shuriken. They're nuts that you can put inside, so that you put a bolt from the outside. We're kind of looking at that as an option instead of field welding. But of course, in that case, then you have to make sure that if the bolts are exposed, if that's going to be okay. If the bolts are being covered somehow, then it's probably not an issue. But if they're going to be exposed, probably not be able to use that. Use of proprietary brand products. Sometimes we'll purchase, say, brackets from like Julius Bloom or Q-Rail or Wagner, different places. We may not follow customer drawings. I'm not sure what that means. I can't remember what that means. I guess it's kind of, we do use different companies' brackets and stuff, but we won't call it on our drawing a Julius Bloom bracket. We'll just call it a stainless steel bracket or whatever, but we'll use their profile and everything else. Bolts, fasteners, screws, that's kind of figured out in the design assist stage with the project manager and the engineer, especially for bolting, posts or something. That's figured out in the design assist stage. Economical and practical lengths and sizes of parts. We just discussed that. Availability and capacities of fabricating plant equipment. That goes back to, I guess, if we're talking about bending material or, yeah, mostly bending material, especially when you get into radius stringers or radius handrail. That may dictate where you're going to have joints on the finished product. But that stuff, again, is usually discussed in the beginning of the jobs with the PM. Every drawing must be clear, complete, and self-contained. That's a no-brainer. Dim style line and line weights. This doesn't really apply anymore. That's kind of when we were all using AutoCAD and everybody kind of had their AutoCAD set up to different dim styles and line weights. Now we're all using advanced steel, so it kind of dictates the dim style and line weights, and it's been set up by Synergy for everybody to use. So at some point, I guess everybody's going to have the same. And the same with textile. It should all be the same because everybody will be using the same software. Do not crowd dimensions. That's Advanced Steel kind of does that for us now, so that's not an issue. Details shall be drawn to same convenient scale. Discussed that before. That's bigger the better, but again, Advanced Steel kind of does that. Are you guys both familiar? Like you'll both be detailing, I guess, in Advanced Steel. Are you guys familiar with Advanced Steel at all, or?
I'm not familiar with it. I haven't worked with it at
No,
all.
neither of us have used it.
Oh, okay. Yeah, I'm kind of in the same boat. I don't really do that much. Well, I hardly do any drafting anymore, but I'm kind of an AutoCAD background. I did do the training on Advanced Steel, but that was a few months back. So if you don't use it, you lose it. But I guess you guys will be learning the new system, and we have outside detailers that some of them are using the Advanced Steel. I think we've got a couple of draftsmen that are still kind of doing SolidWorks. But the Advanced Steel usually spits out most of the drawings to the proper size and everything else. The only thing I have been finding with Advanced Steel is they don't really do a very good submittal erection drawing. Not that they don't do it, but it's just their, especially for spiral stairs and stuff, they just don't really look that nice because they kind of draw it segmented, and so a lot of black lines and stuff. It's doesn't look that great, but we're working on, I guess, fixing that. General detailing, use simple, clear, and properly. That's a no-brainer. When a detail piece is on the far side, it should be noted as far side FS. I think that's in the abbreviation down here. Maybe not. But that's a typical standard, I guess. FS is far side and NS is near side. In designing details, care should be taken to arrange all joints and connections so the work can be built at the shop. That's kind of figured out in the beginning. Goes back to what I was mentioning with like field joints and that. That's usually figured out in the beginning where they're going to go. If customer drawings, we don't use metric. Bolts, fasteners, welding, screws. On some jobs, bolts and fasteners may be indicated on customer drawings. The bolts and fasteners is usually figured out by the engineer. So that kind of covers that. Assembly of different components, post brackets. That's same thing. It's kind of discussed with the engineer and the design assist team in the beginning of the job. For different bolts, fasteners, nuts, we don't use that anymore. We usually, this was kind of a little chart thing we had that we looked at that showed us different types of fasteners. Now we typically kind of go to McMaster-Carr or whatever and find a bolt on there, and they've got, I don't know if you guys are familiar with them, but they have a lot of 3D and AutoCAD details and stuff of different bolts, fasteners, nuts, washers, everything. It's a great site
Yeah,
that I
swiped several of their files over the years.
yeah,
They're a handy
Yeah,
resource.
they really are. They really are. Shop welds or fuel welds must be as per welding standards. We'll look at that a little bit later. Or is that maybe the next meeting we get into the welding a little bit? Third information. Yeah, that's the next meeting. We'll get into the welding a little bit. Submittal action drawings should in all cases give sufficient information that field will not have to study the drawings. Yeah, well, that's basically just you need to show enough information, enough details so that the field can figure out how it goes together. Emailing AutoCAD to Accent. AutoCAD format, that's old, doesn't really apply anymore. This is kind of usually the name I would put like on a AutoCAD drawing if I was sending it to Synergy. I put the project number, the item number, what it is, the item number, this drawing number, rev number. This AutoCAD format doesn't apply anymore. That's
a little old.
That's way old. Usually PM wants submittal and well, PDF format, but that's kind of typical. The PM will tell you what they want as far as format, whether it's in a 3D model or PDF or whatever they want. PM task. Yeah, see CD, DVD. FileZilla, I don't even know if they're around anymore. But yeah, the PM will let you know what they want and how they want it sent. Submittal erection drawings and railings, plan and elevations of all metal and metal glass railings shall include height above finished floor or stair nosing line. That's usually just a dimension from the finished floor to the top of the rail. Support post location, that's usually an elevation. You'll show dimensions to posts. Descriptions of all materials, which Advanced Steel, I think that does that. I believe it'll give a description of an HSS 20 by 4 by half or whatever. Details of attachment to floors and walls. That's just your typical detail of how it goes together. Centerline radius of all bends. I'm not quite sure what Advanced Steel shows, like if you did a radius stair where it kind of dimensions the radius to, if it's to the inside or the outside or the center line, whatever Advanced Steel does, I mean, that's what we'll be using. Location of splices and miters. Yeah, that's usually for your handrail, guardrail. Now that we're doing modular stairs, sometimes the actual guardrail is a panel, modular panel, so we'll have splices in certain locations. So that needs to be shown on the drawings. Can be either be in plan or elevation, with an enlarged detail of the splice. Typical handrail splice. Well, when I send you the kind of not typical, but example jobs, you'll see there's some splice details in there. Some of them are kind of typical that we use over and over again, like for 1.5-inch diameter stainless steel handrail. There's kind of a typical detail that we use. And if you're having problems with figuring out a splice or whatever, there's people in the team there that can help you out with that. Typical handrail termination, bend, miter, and end cap, usually on the architectural drawings for bends. Sometimes when a handrail goes around a corner, it'll be mitered. Sometimes it'll have an elbow. Sometimes we have end caps on the end, sometimes we don't, but usually that's on the architectural drawing, or can be, you can ask the project manager what they're doing on that particular job. Where possible, it's not Accent anymore, it's Synergy standard brackets. Synergy used to make their own brackets, but they don't anymore. That's kind of when they were in the mall guardrail replacement mode. They used to make standard brackets, but we don't anymore, so you can ignore that. At handrail, guardrail, splice, and non-connector sleeve side, handrail guardrail will be 2-inch longer than required. That's if we're talking tube handrail, usually we had an aluminum sleeve about 5 inches long, so 2.5 in the handrail, and then 2.5 sticking out, and that would usually be glued in place. You'll see that on the typical handrails we have. But the piece that butts into that, usually we'd make that 2 inches longer, just so the sight has a little bit of play, like it's not exact. I don't know how easy that is to do in advanced steel, because it'll make it exact when it does a shop drawing. And usually when I'll check it, I'll ask them to add 2 inches in, so I'm not quite sure how they do that, but they do it, so there must be a way to do it. And then I'll put an erector note telling the installer that the handrail's fabricated 2-inch longer than required and site trim to suit. Just gives them a little bit of play when they're installing it on site. When detailing stair elevations, sometimes necessary to show a stair side elevation and an open side elevation. Yeah, we don't really do that much anymore, but if you've got cladding or something, that's usually you'll show the elevation from the stair side, because that's usually where they're erecting it from, especially if it's glass or posts. They're usually working on the stair, but sometimes you need to show the other side, the open side, if there's some material on there that you want them to see, like cladding or perforated panels that might run down to the floor. So you might show both elevations, or you may only want to show the outside, the open side, if you can show enough information on there. Because usually on the stair side will have the handrail, but I guess you could show it like hidden lines or whatever for the handrail if you're showing the outside. So it's kind of up to you guys what you want to show as far as elevation that shows enough information for the installer to understand what's on both sides of the guardrail. How are we doing for time? Okay. Drafting standards, glass. Standards for glass. Used to be a folder for the ASTM glass standards. I don't know where that is now. But usually the glass would show up on the material, the type of glass would show up on the material and finish notes. We used to put the ASTM type of glass it was. I don't think we really do that anymore. So we don't really have to pay much attention to that anymore. That, just wondering if I should send that to you guys. It kind of goes through the different types of glass. Tempered glass, laminated glass. I'm going to make a note here. I'm going to send that to you guys as well. ASTM glass standards. I don't know if that's on Synergy's mainframe or stored somewhere, but I'll send that to you anyways. It's just some information on the glass and how they do different types of glass, like low iron glass, sapphire glass, different types and the different standards. Hole diameter and hole locations for glass. Usually the PM will help you out with that. If you've got like a glass guardrail and there's bracket with holes through the glass, usually you'll need to know how far that bracket is from the edge of the glass. Sometimes the brackets are at the glass joint. Most of the time they're on the panel, glass panel somewhere. And it kind of varies. I think some jobs we've had it like 6 inches from the edge. Sometimes we've had it 8 inches from the edge. Sometimes we've had the bracket in the middle of the glass panel. That's usually kind of, the architectural drawings may show you that. But if not, it may be something that needs to be discussed with the project manager to help you out to figure out where we want to put the brackets. Glass heights above finished floor and widths of each glass panel are to be shown. I'll show an example of that later on. That's just saying you need to show the length of the glass, and then if it's a 1/2 inch joint, sometimes it's a 1/2 inch joint, sometimes it's 3/8. We've had some jobs where they've wanted a 1/4 inch joint, and usually that's shown in elevations on the drawings. Always show glass details at corners. I don't think this example applies or is anywhere anymore. But I usually like to show like a 3 inch to a foot detail for a corner detail of how the glass, what happens at the glass at corners, because sometimes it'll be like this and it'll be a 1/2 inch gap, or sometimes one will run over, or this one might run through, and so it's a good idea to show a kind of a blown up corner example for the installer so he knows what's happening with the glass at the corners. Use a 3/8 inch gap. That's kind of the standard we use, but it depends. It may be shown on the architectural drawings. And if it's something like a 1/4 inch, usually we don't like to use a 1/4 inch gap because it's so tight. So if it's the architect's asking for a 1/4 inch gap, it's something that should be discussed with the project manager just to see if they want to do that or not. I think there was one job that we tried to get them to change, but they wanted the 1/4 inch gap. It just makes it, the tolerances are, if you got one piece of glass that's just slightly out, it's noticeable when you've got a 1/4 inch gap. We don't like to use that, but depends on the architect. Shop drawings. This kind of gets into the shop drawings. Yeah, they're usually done on 11 by 17 sheets. Not actually true anymore. I'm not 100% sure which direction Synergy is going to go in as far as shop drawings, because as I've been checking them, I've found they've some shop drawings that I've gotten, they're all on like 8.5 by 11 sheets. Each piece is on its own sheet. And I've also gotten, I guess, 24 by 36 sheets where there's multiple items. I prefer the 24 by 36 sheet so I don't have 300 drawings to look at. But it kind of depends on, I'm not quite sure which direction Synergy is going in. But the standard title blocks that I'll be sending you, I think there's a 24 by 36 shop drawing in there, and I think there's also an 11 by 17 shop drawing. The 11 by 17 shop drawing size, I guess, is good for if you just have a couple of pieces you want to send to the shop or something. But there's a standard title block in AutoCAD that we can use. Dimensions should be arranged in a manner most convenient to all who must use the drawing. And that's kind of done by the Advanced Steel software. So, and I found that the way the dimensions that are usually set up is usually pretty good. See section of general detailing and procedures before detailing. Well, we just kind of went through that. Material type is to be shown directly beside detailed piece. Advanced Steel does that. That's on the drawing. This doesn't apply anymore. That was something we used to do with the shop. Shop welds are to be, that's kind of, we went through that already. Shipping mark numbers. Yeah, mark numbers for pieces. That's kind of, we used to have standard shop drawing numbers we use, but Advanced Steel kind of generates its own marking system now, which is fine. We're kind of adopting that now. It seems to work, so. Shop drawings should always be cross-referenced to submittal direction drawings. That just means that the down in the bottom of the title block for a shop drawing, there's usually a reference box that just refers to the correction drawing that piece, that member is shown on. Item number to be filled in to match scope of work. That's just the 2 digits in the front of the number we went over. Shop drawing should always show material finish. Correct, and that's the same thing in the bottom of the shop drawing. Along the bottom, there's a little box there that you can put, if it's a stainless steel piece and has a number 4 finish, that's where you would put the number 4 finish. Show grain direction of finishes. Sometimes if it's a number 4 finish, we used to put kind of a little arrow on the material showing if it was a long piece, if the direction of the finish was along the long surface, we would put kind of a little arrow kind of pointing both directions, showing that was the direction of finish. But if it's number 4 finish in long direction, that can also just be put in the bottom, in the template at the bottom. Number 4 finish with grain running in long direction is fine as well. Bevel cuts, bends should be shown. That doesn't really apply anymore. We used to send bend drawings to different manufacturers to get bends done, and provide them a drawing or whatever to make bends and that. I don't think that really happens that much anymore. I think we just send them the drawings that Advanced Steel spits out and they figure it out. When detailing guardrails or handrails for shop fab that are shipped loose to site, show pieces. Yeah, I think we discussed that a little bit. Just add a little bit for handrails so they can site trim. And detailing bent sheet material, cladding, fascia, always dimensioned to inside profile. That doesn't really apply. Advanced Steel kind of dictates that now, but you need to ask the project manager. I guess the allowable bend length, 10 feet or 12 feet, is usually the two lengths. Check with accent if backup bars are required at joints. Sometimes when we do cladding, they want a backup bar at a joint, so there's no, if the seams open a little bit, you can't see through. Don't really do that much, but it's a good thing to ask. Usually it's like a 20 gauge 20 gauge cladding that we would use, but needs to be asked, I guess. A lot of these folders that refers to, I don't know if Synergy even has these anymore. So I would ignore, I guess, this, and if you have some questions, just ask your project manager. Sometimes when shop drawings are detailed, a detailer must have several pieces that are identical, but that doesn't really apply anymore. We used to, instead of having 20 drawings of something it's the same piece, but it might be different lengths. Instead of having 20 drawings of 20 different lengths, sometimes we'd have one drawing and we call one as A, MO1A is 10 feet, MO1B is 15 feet, MO1C is 16 feet, just to cut down on drawings. But Advanced Steel kind of spits out what it spits out now, so that doesn't really apply. I think it would make each piece different now, but it is what it is. This is just some examples referring to different folders where I had different examples. I don't know where those would be now. But I will send you sample jobs, so it will kind of help you out with all of these different details, kind of showing what needs to be shown. And Advanced Steel also kind of spits out what it spits out as far as details of shop drawings. Shop detailing radius, rolled or break form members, check with Accent. Project manager, it's not Accent Synergy, sorry, to find out maximum length of material that can be rolled. Yeah, let's kind of discuss that already. When detailing long runs of handrail, guardrail, check with Accent. Find out, we discussed that already. This kind of goes over different things we've already gone through. But this kind of goes on and on, so I'm not gonna keep going on and on. I'll send this to you guys and you guys can go through it. Like I say, a lot of stuff might not apply anymore. Tempered glass logo, that's something sometimes we do, sometimes we don't. Sometimes we ask the project manager, and instead of a logo, they just give the customer a letter saying that a certificate, I guess, and will be provided in lieu of logos. Because logos are kind of a pain in the butt, because you got to kind of you want to kind of keep them all in the same place.
Yeah.
But when you're flipping
More
glass,
consistent.
yeah, when you're flipping glass around and that, sometimes they end up in, the wrong places, especially on stairs. If you have a panel on both sides of the stair and you put the logo always down in the bottom right hand corner, well, then it would when you detail it, it would end up in the wrong corner for the one opposite, so they'd be kitty corner.
Mhm.
So we try and get away from logos if we can. Usually probably have a job here somewhere. Usually we'll put a note in the material notes about the logos. That job didn't have glass. Let's find a glass job. Atrium ribbon stair. Where's the other one? I thought I had Rutgers glass. I guess I didn't. Okay, sometimes it's noted in the material and finish notes. Guardrail, handrail. Yeah, that's for the stair. Sometimes we'll put that in there that instead of a logo, we'll give them a certificate just saying that it's tempered glass. But that's something that needs to be discussed with the project manager. Always detail glass and laser cut pieces, full scale. That's kind of Advanced Steel does what it does. Detailer to follow review. Estimators takeoff sheets. We used to a long time ago, when we detailed a job, we'd get takeoff sheets from the estimator and we could kind of check that as we went along, just kind of as a double check to make sure no materials missed, but we don't really do that anymore. Detailer to follow review ASTM glass standards. I'll send you that. Then we kind of get into some of the mark numbers that we would use, but it's been kind of set up. It's been set up now. I don't know if we're using these anymore because Advanced Steel kind of spits out its different marking system. We used to, if we had a piece of glass, it would be, if it was item 1, it would be 01G01, 01G02, 01G03. And for handrail, it'll be 01H01, just kind of as an indicator. But now that we've kind of come up with a standard, this is actually an erection drawing, not a shop drawing. But Yeah, just let me see here if we've got a, let me just open up a shop drawing here and see what it looks like. It probably doesn't have a, it's not in this folder, probably doesn't have a mark number on it, I don't think. Is it in here? No. For stairs, sample jobs, those are all sample jobs. Can't remember where I put it now. There it is. Architectural D, A, D. These are all D. Single. See if that's it. Yeah, I guess this is the shop. The shop drawing, but he doesn't have a mark number on here. But FD, I guess, is for fab drawing. And this number would be changed. So if it was, if you were detailing a piece of glass, it would, and it was item 1, it would be 01H, or sorry, 01G01 if it was your first drawing. I believe that's the way it should be marked. Edward may say something different, but I think that's the way it should be marked. But it's, again, in Advanced Steel, I think actually Advanced Steel kind of spits out its own drawings. I just want to see here. Yeah, see, this is an Advanced Steel shop drawing, and it's got a totally different number. It doesn't even use the, like, this is a guardrail. It doesn't even have a G number in it, or a G letter in it. So I guess Advanced Steel does what it does, which is fine. As long as that number is on the erection drawing for the installer, I don't have a problem with the way the drawings numbers marked. But that's his drawing standards. That's kind of what we used to do. Probably the guys detailing in the office probably do use these letters, but the drawings I was showing there, they're an outside outfit, so they're obviously not following this. But when I check it, I just leave it. It's fine as long as it works. That's the main thing. Oh. Yeah, like I say, I'll just, I think we should move on to something else here. It's just, I'll send this to you guys and you can peruse it. And if you have any questions or whatever, just let me know and I'll answer them as best I could. Drawing lists don't do that anymore. They're complete, detailed, published original to the accents. Yeah, that's just, you send them to the project manager once you're done. What else we got? Synergy, broad intro to stairs. I just opened this up here. These are some sketches I made at one point. I was going to do kind of a lessons learned file, I guess, for Synergy. It kind of got part finished. I never finished all of it, but these were some of the sketches I made. When detailing elevations, glass joints on stairs, just to be aware that sometimes they need to be lined up with window mullions or reveals in wood or whatever. Just something to keep aware of, but that'll usually show up on the architectural drawings. We do use control lines on jobs. That can be discussed with the PM. And the control lines help the installer install glass in that. Like if the if we knew, if this control line was like 5 foot off a grid line and we knew where the window mullions were going to be on the drawings, and the window mullions weren't there yet and we were installing the glass, then we could use the control line and set the glass, and then we know it's going to be in the right spot when whoever puts the window mullions in, or the millwork reveal or whatever it is. So it's a good thing to use control joints. This is where we get into some of the codes, building codes. Synergy, typically height of hand guardrail is usually 42 inches, which is 3'6". We usually go a ½ inch bigger just for kind of a safety thing, just so we're always above code, because sometimes if the finish on the stair is added, if it's terrazzo or something, it may be shifted up or down or whatever as he adjusts it, and it may affect that. So it's always a good idea to be a little high than being right at 3'6", and then being under code because this is up higher than it should be. As far as the handrail, minimum for handrail is 2'10", 34 inches, and high, and it's usually 2'10" or 3'2" or 3 feet. 2'10" is the lowest. So if the architectural drawings are show 2'10", we usually go 2'10.5", just so same thing, we're a ½ inch above code. If they show 3 feet or 3'2", then that's fine. You can leave it, because it's, even if it's 2'11.5" or something, we're still above this code, so we're okay. And then the top of the stair, usually a foot. Bottom of the stair is usually a foot. Sometimes it's 1 tread plus a foot. That's usually shown on the contract drawings. And then we get into, you guys are probably familiar with this for code. 4-inch sphere can't pass through, and a 6-inch sphere on the stairs can't pass through. The 3'6.5" again. The headroom, usually 6'8", although I think New York is 7 feet, I think. But it needs to be checked. Make sure that we're within code. You don't need if you're more than, you need guardrail required of more than 30 inches. Yeah. So if it's 2'6" or less, you don't really need a guardrail. And then usually the standard for code for rise and run is 4-inch minimum and 7 3/4 maximum rise, and then 10-inch minimum run. Nosing is 3/4 to 1.25" max. If no nosing, minimum run is 11 inches. So I'll send you this stuff as well. You guys are probably familiar with this. The width minimum 36 inches, but that depends on what the stair is being used for. I think it can go up to 44. I think some are 44 inches, I think, in some cases, depending on the type of stair. Usually the stair width and the landing width are the same. They like to keep it the consistent dimension as you're going around a landing. Minimum 2'3" between handrails. Sometimes a mid-rail is required depending on the width of the stairs. That's just something to keep aware of when you're detailing a stair, because sometimes you may do a job and the stair doesn't show a mid-rail, even though the code says there should be a mid-rail. But sometimes it depends on whether the mid-rail's there or not, is because of the type of stair it is in the building it's in, type thing. So that kind of dictates whether one's required or not. But if it's not shown and the code says it should, it's just a good idea to kind of ask, make sure that it's not required if it's not shown. And these are some minimums for handrail clearances. This dimension here, 1.5 inches. I think some buildings, they like to go to 2 1/4. I think, yeah, for the firemen, I think they like to, yeah, to get their glove in there or whatever. I don't know if that's going to become a standard at some time, but right now it's still 1.5 inches, unless told otherwise. This is just kind of what we do usually at a finished wall. When we have a glass rail, we'll usually leave a 2-inch gap. And then the joint, as I was mentioning before, it's usually dictated on the contract drawings. If not, we usually use 3/8 of an inch. That's kind of our standard. This is just kind of a sketch I made in regards to site measuring. I used to go to a lot of job sites and do a lot of the site measuring for different stairs and stuff. If we had a rail around the balcony, this kind of pertains to that. Sometimes the floor around an opening it's up and down. So what I would do is find the benchmark and get the GC to tell me where the finished floor is going to be in regards to the benchmark. And then our rail would be built 3 foot 6.5 inch above whatever he says. Because sometimes, I mean, this is exaggerated, but sometimes the floor can be pretty wonky. I always find that they dip in the middle, especially old buildings. If they're an old building, if you have 2 concrete columns, the floor always seems to be lower. In between, they sag. But it's always good to work with benchmarks so that we know exactly where the finished floor is, so that we can tell the installer that's where you need to be off the benchmark. And this is what I was kind of just discussing. I would go around an opening and take a measure every 6 feet or something and kind of find wherever the high point was. And then the high point, that's where, like if it was just a concrete floor, a polished concrete floor or something, I would find the high point, and that's where the 3 foot, I would find the benchmark, find that high point, and then go 3 foot 6.5 above the high point. Why is this stupid thing on here? Oh, there. Yeah. So I'd work from the high point. And we don't, us draftsmen, we don't do any of the site measuring anymore. Now we have teams that go out and do that. And usually we'll get a heat map or a cloud point, which kind of gives us that information. And this sketch was kind of in regards to control joints. Same thing, control joints help the installer set the stair. If we know where the grid lines are, we can set control lines off the grid lines and give dimensions to the control lines. We don't really put that on our drawings anymore, but it can be added if required. And benchmarks, again, very important for the installer in the field to know where the finished floor is. And then if this is 36 inches and our drawings are showing the stairs 2 inches above finished floor, then he knows that this is 34 inches when he's installing it on site, whether the floor is there or not. And these last sketches here, they're kind of in regards to how the handrail and guardrail end at landings. Sometimes you don't have enough run to flatten out and go around a corner. So we do different scenarios. This is one scenario where we do have enough room to flatten out for the handrail and the guardrail. So you get a nice even, all at the same level around the corner. This one was a little bit different in that we made, in order to keep it all level as we went around the corner, we actually made this higher instead of 3'6.5", so that we could get our diagonal flattened out and then around the corner scenario. So that's an option as well. Sometimes you can make, instead of being 3'6.5", you can go to 3'8" at the landing, just to make it work. Or we've had actually a couple of jobs where we did this kind of scenario, which is not preferable, but some architects seem to like it. Probably won't see that one too often, but different examples. And then this is another example where you show a gooseneck. Some architects don't like goosenecks, but we have done them in the past. And same thing, this is to keep our 3'6.5", and then because we don't have the 11 inches of run or whatever, we're up higher up this point. I think this scenario we showed, that this is like a CRL Lawrence stainless steel top cap, and we just ended it, put an end cap on it, and then this was a separate piece, and then this piece was a separate piece with an end cap on the end. So different options, but these type of, depending on how much run you have, that's something that can be discussed in the design assist meetings or with the project manager on how exactly this is handled. Different options. So that's those details. I'll send that to you guys as well. That's kind of the broad intro and synergy standards. Next we have arrangement of drawing sheets. That's basically this AutoCAD that we were looking at, which I will send you, cover sheet. And there's a couple other drawings in there as well. Let's see what else we got in here. We got architectural D cover, which is that one we're looking at. And then there's architectural D. I think this is probably a D size shop drawing, maybe. Yeah, this is just a different, I guess, a blank ED. I guess this is what you would use for your, it's not the cover page, but it's an erection drawing you'd use for your elevations and plans. What else we got in there? We got this one here, an assembly. So this is an assembly drawing. So this would be your field draw, your fab drawing, cover page on 24x36. So it looks like we're probably going that way, I think, with the, I guess, the assembly and the parts. Or does he have a part drawing here in this folder? Yeah, this looks like a part drawing here. But we are, yeah, this is a part drawing. So we are using the 24x36 for part drawings instead of the single drawings, which is good. So I'll send you that folder. And if you have any questions with that folder, with the actual templates and stuff, Edward's, I don't know, have you guys met Edward Garcia?
Yeah, we had a meeting with him yesterday.
Okay. He's kind of the one who set up the erection drawings and that. So if you've got any questions, I guess, with how to use it or whatever, he's kind of the guy for that. Or one of the other draftsmen can probably help you out. We do have I don't know if you've seen it yet, but there is on Microsoft Teams, there's a page on there, a chat page, which has all the detailers on it. So if you have a question or something in regards to an advanced steel question or something, you just throw it on there, and usually somebody in the team gets back pretty quickly to help you out, which is great. Next, we have preferred plot styles, sheet layouts, line weights, hatching, fonts, layers. That's doesn't really apply anymore because it's all done by Advanced Steel now. So, and that's been set up by Synergy as far as line weights and hatching and fonts. All that stuff has been set up by Synergy, so that everybody that's on Advanced Steel is drawing the same thing. Information necessary to be shown on plans, layouts, elevations, sections, details for submittal on assemblies and part drawings for fabrication. So I'll basically just go through, I guess, a job we've done. This is, go through this one. Maybe I'll go through this one because it has the assembly and part drawings attached to it. This is a drawing or a job that's in the works right now. It's Fordland. There's 15 different stairs on it. It was subbed out to a different outfit to detail it. It's actually a shop drawing. Okay, let's go back here. Find what I'm looking for. Okay, so this was done by an outside detailer. So he basically, in the beginning, he detailed the submittal erection drawings, or IFA drawings, I think we call them, which is issued for approval. These drawings have been back and forth quite a few times, so they've been because the shop drawings were detailed, they've been kind of updated. Just some erector notes and stuff have been put on that weren't in the original IFA set that went for approval. This is more now for the guys on site as far as erection and stuff. So this particular job had 15 stairs. This is one stair. It's item number 3. This should say E01, not E00. We don't do the E00 before. I think in this drawing standards, I think that still mentioned this E00, and that was because if you had a big job and you had 15 items and each item was like 01, 02, 03, 04, it was sometimes packaged in the same job or set of drawings, and the cover page instead of being E01 or item number 03, we use 00. That's what the 00 came from, but this should be E01 now. So this was item 3, and it was broken into, we don't do this on all jobs, but sometimes we do. We break the job into 2 parts, the stairs and the rail. And the reason we do that is so that the stair can go through the approval process and come back, and the engineering process and all that gets done, and then it can go to the shop before the rail goes. So because the stair they want to put in first, and then the follow up with the rails after. So the project manager will say, let's break it into 2. So we'll do a set of drawings for the stairs and a set of drawings for the guardrail. So this set was the set for the stair. This was one stair, and there's a key plan that shows where it's located on the job site. And the next drawing was a larger key plan that just kind of pointed to the same thing. And then it got into the third drawing is sometimes we'll put an isometric view in there. I guess from the model that's created, you can just take a couple of snapshots or whatever and add it in. And then it gets into the plan view, and don't think he has a mark number on here. I think he actually put the mark number on this piece. Yeah, there's the mark number. So there's usually a plan view, And it'll have call outs on it for sections and elevations. And this, it'll describe all the structural components of just the stair for this set of drawings. Elevation of the other side. And a couple of the elevations at the top of the stair, and then it gets into some sections and details. And we do, if the drawings have been revised, usually in the design assist phase when we're going back and forth with changes and that, we don't change the rev number on it. We'll leave the rev number as 0 because it hasn't gone for approval yet. And we'll change the date every time we issue it for checking or whatever. We only usually really do the rev 1 after it's been gone for approval and come back, and then we'll mark it up as rev 1, especially if it needs to go back for, if it's like revise and resubmit, if we have to send it back, then it's got a rev 1 number on it. And sometimes it might have to be revised to suit site, possibly. We're trying to get site dimensions early in the stage of detailing erection drawings and that, so we know what our floor to floors are, so we don't have to revise them, because it's very difficult, I guess, or time consuming, I guess, to revise the model if the floor to floor changes. So it's nice to get that up front, and I think Synergy's been trying to been trying to get that information as soon as possible. And some more details. So that's the stair structure set, and then this is the rail set. And it's basically the same set of drawings, just showing the guardrail. This stair just had a handrail on this side up, and then up this one tread stair, and then down the sides on this side. So same thing, you have a isometric view and then a plan view showing the handrail and then your elevations. And these are the splices I was talking about. Usually you locate the splice and then you show a detail. So there's a detail for the splice at the guardrail, which is a HSS 2x2 buried in the wall. And then you have your handrail, you've got a splice and a splice detail for the handrail, which is that's our guardrail splice. Because it's buried in the wall, we can just weld it because you're not going to see it. And then for the handrail, where was the handrail? The handrail splice is E12. So C12, 16, 15, 14, 13, 12. Yeah, this is a typical handrail splice. One side's has the glued sleeve, and the other side is glued on site in the field. It actually doesn't have a note here that this side should say note to erector. This side is 2 inches longer than required site cut to suit, but when I check the erection drawings or the shop drawings, I make sure that the handrail is 2 inches longer, and they can figure it out on site. It's better to be longer than shorter. So that's the railing set. And then we get into the fab drawings that, where did I put them? Yeah, these are the fab drawings. This is just the stair or the rails. Yeah, this is the stair. So this is the stair set of shop drawings. You have a assembly drawing, there's an isometric and a plan. Shows some dimensions. And then the actual shop drawings. This particular stair was made in one piece, and we were able to do that because we could get it into the building and it can be shipped all as one unit. And elevations and just showing details. And when you get into the details, that's when you get into the welds. Welds that are required. Usually no paint. If these are concrete filled pans, so there's no paint on the inside. Or on the landings, no paint on the landing pan. And not sure why, when they did these drawings, they didn't really need to show this field welds because they're shop drawings, but they just kind of copied it from the erection drawings and added it. So I just left it. So different details, more details with all the mark numbers, all the pieces. And then they get into the actual shop pieces. And this is where, like I said, it's on a 24 by 36 sheet, which I prefer. And I believe this is advanced steel as well. So I guess this is what it spits out as far as details. All the different pieces. It's got the hole size. This piece is shipped loose. I think that's the angle at the bottom of the stairs. You leave it off so it's this piece here, so it's adjustable if needed. And more parts. And the pans. And I'm pretty sure I think this is created by Advanced Steel, so these are the type of drawings we get. So that's kind of a typical set of shop and erection drawings, or IFA drawings, I guess they call them. What else we got here? For information from job description, daily tasks, and project process as seen from DW perspective. Well, job description, mine's checker. I guess you guys will be detailing, so I guess your job description is detailers. Daily tasks, the draw. And project process, process is usually we have a huddle, drafting. I'm in drafting team number 1 huddle. I'm the job captain for that. I have 3 draftsmen that I talk to every day, and we have a smart sheet. It's called a task tracker, and it's got all the jobs that each detailer is working on, and it's got completion dates. And I meet with them on Monday, Tuesday, Wednesday, and Friday, and we go through that task tracker and just kind of keep track of where they are and how the job's coming along. So that's kind of the project process. And anytime a date is, if it needs to be changed in the task tracker, whoever the project manager is, and they're listed in that task tracker as well. If I change a date, they get notified that the date changed. So if it's a problem or whatever, they'll let us know. I'm not sure if you guys have been assigned a team number yet or not. Edward is
yesterday.
Okay. Edward's kind of the manager, drafting manager, so he kind of takes care of who's with who. I think he's team number 4, I believe. And there's Jason Hudson, he's team number 2, I think. And I don't know if we have a job captain for team number 3 or not. But that's up to Edward. He would assign which team you're on and who you report to each day if you need to report each day. But I guess Edward would be setting that up. That's about it for today. I guess we still got a half an hour left. What we could do, I guess, is go over another job, I guess, that I've got here. I think you guys are probably lined up to go for some training with Denis Lamoth probably later in the week. He's been with Synergy for quite a while as well. And this is one of his sets of drawings. It's the cover sheet, and that is old because this job was like from 2016. But this is a set of drawings he did for the JFK Center in Washington, D.C. I don't know if you guys are familiar with that place. This was an addition to the theater. So it's kind of I think they kind of made it, it's kind of for, they can have meetings and lunches and dinners, and I think there's rooms for, ballet artists to train and stuff like that. So kind of an addition to the actual theater area. Synergy spent 3 years on that project, I believe. There was quite a few items. This was one item that Denis Lamoth did. Item 3, it's a guardrail and a stair. So we'll just kind of flip through the job. I don't know if you guys will ever have a chance to go there. It's pretty interesting. This particular job, we had glass guardrails, and the glass guardrails were in shoes, but instead of shoes, sometimes there'll be a support angle underneath, or we'll be anchoring them to concrete. This particular job, we used these Hilti anchors. They were called Hilti hack anchors. So we had to show the location of each of these anchors. Originally, what had happened was Hilti does make these anchors in longer lengths. I think we actually have a picture of one of them somewhere. I can't remember. They did make them in longer lengths, but what happened was we asked to order them, and they said, well, they take, so if they're not like an in-stock product, you have to order them way ahead, and we didn't have the time to wait for them, so we had to use what they had in stock. So we had to use all these, I think they're 12-inch long anchors, which was kind of a nightmare because we had to tell whoever was setting them in the formwork exactly where each anchor went. So Denny spent a lot of time on these drawings, locating all these Hilti hack anchors, so that when we did our shoe, it was matching up with these anchors. So that's the stair, and this was an elevation of all the anchors down the stair. That's a section through showing the anchor. And then this was the plan showing where all the anchors are. Kind of a curve here and a curve here, and then down a ramp here. And then this is the stair we were looking at up here. And then there's an L-shaped kind of area over here. And just some elevation showing where all the anchors are. And more of the anchors. And more details of the anchors around the curve. And more details. and then the anchors around this area. And we also had to show where our core drills were because the handrails were lighted. So we had to have hollow tubes set in core drilled holes and with a conduit with the wiring for the electrical. So we had to tell them where all the core drills were. We had to locate those as well. So it was a lot of coordination. These are in the walls. There's also holes in the walls where the handrail would connect, and same thing, the wiring would come through. There's some details of that later on. And then this is where we get into the actual guardrail. And the stair, showing the glass on the sides of the stairs. And then we get into the elevations. These are the actual glass panels, and they're very, very large. The size of the panels, I think I'd mentioned before, it's kind of dictated what's shown on the contract drawings, and as well as what Synergy. If we look on the contract drawings and it looks like it's too long, we may need to go to whoever's fabricating it and just make sure that we can make it that long. So that's something that needs to be checked. And this is one particular job where we had a 1/4 inch gap. And I think we tried to get them to change that, but they were adamant about a 1/4 inch joint. And this shows the excuse me, shows the joint for the field joint for the handrail. This particular elevation was taken on not on the stair side, but on the outer side, which is because we wanted to show the shoe as well in the elevation. So instead of showing the stair side, he showed the outer side, which works because you can see everything, as long as you can see everything. And he's got all the marks for each piece of glass. And then this is the other side of the stair where there was a wall rail. It was anchored to the concrete wall up to about here, and then there's no more wall here, so we added posts that were set in core drilled holes. And same thing, these he has a drawing that shows exactly where that core drill hole is, so they could locate it on site. And I think the wiring, I don't think this rail was wired against the wall. I think it was the glass rail that was wired, electrical lighting. And just some details and then some elevations. It's got all the piece marks on it. And we had some cladding here, I think. No, it was gypsum board. Just a detail of a gate. I think they didn't put this gate in. That gate was at the top of the stair here. Actually, I guess on this one. Yeah, I think it was over here. I think they decided not to put that gate in. And then the L-shaped area, you had a wall rail here, and then around the opening. And some elevations of that same area. And then we get into the details. This is the side mount shoe. So we have the Hilti hack embed, and then we had a bunch of shims. And the shoe went to, the bolt went through the side of the shoe into the Hilti hack, little T-bolt. And this is a detail along the side of the stair. Same thing, there's your Hilti and your glass. And then this is just a section through the glass, and then he also shows blown up details, which is good, which shows all the different components that were used. The shoe, the nuts, the bolts, the cladding. Oops. All the different bits and pieces. And then more sections, more details, more details. This detail was a plan view of the shoe at the curve. We couldn't get the shoe curved. Not sure why at that time, because I know now we've done some jobs where we have had the aluminum shoe rolled. But I think at the time that was an issue, so we actually made this shoe out of steel rolled plates. I think quarter inch thick plates. Yeah. So we actually built the shoe. That's something that needs to be questioned, I guess, with the project manager, if we can roll the shoe or if we have to do something else. And just a few more blowing up details, and then we kind of get into the handrail bracket details, I believe. More details of the handrail. And this is the handrail. It was field welded to the bracket arm, and then the bracket was attached to the glass with a countersunk screw. We had a neoprene phenolic machined insert washer. It's plastic basically in the glass. The guys on site had a lot of fun with this washer because it would squeeze into different shapes and stuff. One of the issues we had with the, not issues, but things we found with the rail, same thing, the manufacturer couldn't roll this particular type of top cap because it would just squish. So we had to use this type of molding up to this point and stop it and shop weld it, and then same thing, that type of molding up to here and stop it and shop weld it, and then this piece was a no channel piece of handrail. So it was just a typical round tube that we had to use at this point, and then the wire would just go through it. But because they couldn't roll this, it would just mush or deform or whatever. So we had to stick in a piece. But that's something that's you usually find out in the detailing process. The project manager will let you know something like that if they can't roll a piece or something. And this is your typical splice, handrail splice. Same as the one we were looking at before. And then this is a bracket connection where we're attaching to the wall. In this case, there's different ways of attaching to a wall. In this case, we used Calm Power certs, just a chemical anchor, and they're just glued in place. You drill a hole and stick them in and glue it, and then it sets, and then you can drill, and then you can insert your screw into that insert. We've used them on a few jobs. There's all different types of ways of anchoring in that, but it would be something you would discuss with the project manager and the engineer too, has to sign off on what type of connection we're using. Sometimes we're told that in the beginning of the job, or sometimes we'll just decide to use that and then send it for engineering and see if they sign off on it or not. And this is what happened at the ends of the handrail runs. They actually stopped them with a bracket and did this kind of wonky bracket at the end. A little bit different way of stopping your handrail. And then this is a handrail connection where we had to run into the wall. Same thing, we had to tell them where that hole was so that the electrical could put their conduit and set it in concrete, so we could set the wire through for the lighting. So fun coordination. And then we had to go out and site measure and just make sure that hole was where it was supposed to be. And I think this job actually was one of the last jobs, I think I was doing a lot of site measuring. So that was quite a few years ago, I guess. 2017, so 6 years ago already. But they have new teams that go out with scanners